Good afternoon. It's my pleasure to join you this afternoon. My goal will be to talk with you about the same sorts of things that Meredith did, but with respect to mathematics. How can and are the employability skills integrated into the CCR standards for mathematics? And just start to give a window into how instruction might be structured so that the CCR can be more visible, and hence the employability skills framework would be more visible in the classroom. Could I get the next slide? Thank you. Meredith talked a lot about the criticality of the English language arts literacy standards with respect to workplace readiness. And a lot of what she said actually applies for mathematics. Meredith talked about problem solving. She talked about reasoning. She talked about precise communication. And all of that applies also to mathematics. But I pulled a quote from a publication that a group called Achieve Incorporated did. This was a quote from a manufacturing and distribution executive, and it actually applies more specifically to mathematics. And let's just read through that together. It says, increasingly the computer will do the computation, but thinking about the problem, developing the problem, understanding the problem, and looking at it from all sides, deciding what is important information, what's relevant to the problem, that's the harder part. And you can't do that without an understanding of the computation itself. And this was from a frontline manager, so it just shows that mathematics is more than just number crunching. It's also understanding problems, looking at them from multiple perspectives, and persevere in solving problems. And of course you need the mathematical skills to do that. Next slide, please. Achieve, which is the group that I mentioned earlier, has done a lot of survey research with post-secondary folks, but also with employers. And as I said, specifically with frontline managers, because the question was not what will an executive necessarily in a place of employment, what will they be required to do, but what will workers on the front line be required to do? Achieve also collected from colleges samples of assignments that students would need to do, and from employers they collected examples of workplace tasks that entry-level workers would be required to do to get, and these tasks give a sense of what the expectations are with respect to mathematics. There is convergence in the research around the mathematics that employers and post-secondary institutions require. That statement sometimes gives folks reason for pause, but we're not talking about someone in college necessarily going on to be a math major or an engineer or a computer scientist. There are a lot of 2-year and 4-year college degrees that require problem-solving skills, decision-making skills, reasoning skills, precision in the mathematical skills, and there is some convergence between what employers expect and what institutions of higher education expect. If you want to see some examples of how mathematics is used in a variety of workplaces, a good place to look would be to go to the Achieve website, which is www.achieve.org, and they have a number of brochures online called Mathematics at Work brochures, which deal with a number of different workplace settings. For example, aerospace, medical, manufacturing. And they give some very brief but specific ways in which mathematics is important in those various workplace settings. Next slide, please. One question is, how do the CCR standards for mathematics reflect the employability skills? The CCR standards are aligned with the mathematics knowledge and skills that are required for workplace success. And that includes three different aspects of what we talk about when we talk about rigor in mathematics. Procedural skills and fluencies, the procedures that you expect students to be able to do with respect to mathematics. Maybe computational, it could be measuring, it could be data collection and data analysis. Conceptual understanding, it's important for students not only to know how to perform mathematical procedures, but also to have an understanding of why things work. For example, we always tell students in order to divide fractions, you invert the second fraction and multiply. Well, that's lovely, but why? And if students don't know why they do something, it's much harder to make sense of it and to remember it, because if it doesn't make sense to you, you're probably not going to remember it. The conceptual understanding that's important there is the inverse relationship between multiplication and division, which is why you invert and multiply. And finally, the CCR standards, the third aspect of rigor is application. Not only is it important for students to know how to add, subtract, multiply, and divide and measure, but they need to be able to apply those skills in meaningful mathematical and real-world problem-solving situations. Next slide. Whoops. Okay. Another component of the CCR, which is very important, is something called the Standards for Mathematical Practice. And these are a set of 8 standards that overarch all of the content-specific standards and are expected of all students, whether they're going directly into the workplace or intend to pursue some sort of training as part of the workplace or to get a job. How does the employability skills framework align with the CCR standards for mathematics? That's kind of the flip side of what we just talked about. As Laura had said, there are three categories of skills. One of those was applied knowledge, and the, academic skills and critical thinking skills are the skills that are associated with applied knowledge, and they are both reflected in the CCR. Effective relationships are not as explicitly present in the mathematics CCR as they probably are in English language arts literacy. However, that doesn't mean that they don't exist there, and I think where the implication for effective relationships comes into play in how teachers teach mathematics in their classrooms. The way that it's taught can certainly be used to be effective to enhance interpersonal skills if you have students working together. And personal qualities are also a critical element of solving mathematics problems. For example, being persistent and persevering in solving a problem. If you try it one way and it doesn't work, you give it a shot and try it some other way. So they're not as explicitly in the CCR, but they are an expectation with respect to the mathematics classroom. Next, please. Workplace skills are also evident in the in the CCR. The ones that are probably most explicit in the CCR would be information use, communication skills, and technology use. Resource management can be there depending on how you apply the mathematics skills. If you're working with students and give them a problem to solve that deals with personnel management or budget management, you will be addressing that aspect. But it's not as explicitly spelled out in the CCR as some of the other ones. Information use is clearly evident in the section of the CCR that deal with data and statistics use. Communication skills are there. We expect students to be able not only to solve a problem, but to communicate what they did, how they did it, and to be able to defend what they did, and to be able to critique the reasoning of others. Systems thinking could be there, as I spoke about with resource management. And technology use is certainly evident in the CCR and should be evident in the mathematics classroom. The use of technology could include the use of scientific calculators, the use of graphing calculators, the use of computer software, statistical software, and technology can mean things such as the use of different types of tools that are measuring tools, for example. Next slide. How do the CCR standards for math reflect applied academic skills? Next, please. For those of you that are not overly familiar with the CCR are organized by level, with level A being beginning ABE, level B, ABE 1, level C, ABE 2, level D, ABE 3, and level E is ASE 1 and 2. Within level, they are organized by content domain, which would be for number, algebra, geometry, statistics, and probability. Next. And we've already talked about the standards for mathematical practice. So I don't really think as I said, they overarch all the content domains and all of the levels. I pulled a couple of examples just so that you can see how the applied academic skills are reflected in the CCR Math Standards. Both of these are from level C, but this sort of standard is evident in all the levels. The first one says solve real-world problems involving multiplication of fractions and mixed numbers, for example, by using visual fraction models or equations to represent the problem. So we're getting at the aspect of solving real-world problems using a variety of methods that students can apply to solve the problem, either some sort of modeling or translating it into an algebraic equation. Another example, apply the area and perimeter formulas for rectangles in real-world and mathematical problems. Finding the area if you're tiling a floor, finding the area so that you can calculate how much tile or how much wood you'll need for your floor. These are the standards for math practice that I've referred to, and I just want to walk through them so you'll get a sense of what it is we're talking about. The first one, ignore what's in the parentheses. That's something I'm going to talk about in a bit. But the first math practice is make sense of problems and persevere in solving them. The second, reason abstractly and quantitatively. The third, construct viable arguments and critique the reasoning of others. 4 is model with mathematics. And each of these practices in the CCR document is accompanied by a paragraph that kind of fleshes it out. So if you don't feel real comfortable with what modeling may mean, Look in the CCR. There's really good descriptors for each of these. Use appropriate tools strategically. Attend to precision. That means in mathematical calculations, but also in precise use of terminology, notation. If you're graphing something, attending to detail in the graphic. Look for and make use of structure. Math is noted for structure and patterning, so that's something we want students to be cognizant of and to be able to look for as they're solving problems. And look for and express regularity in repeated reasoning. What I did for the first math practice, you'll see something in parentheses. What I did there was I just tried to think through for myself which of the employability skills framework skills do I think is most closely associated with that math practice. I think applied academic skills for sure, because if we're solving a problem in a mathematical context, students are going to have the academic wherewithal, the mathematical skills to tackle the problem. Critical thinking skills for sure, they're going to have to make sense of the problem, figure out what it means. And personal qualities, the whole thing about persevering and problem solving. That's really a very critical habit of mind that we want to develop in our students. If I try it once and it doesn't work, let me tackle it from a different angle. Let me try some different ways. The whole perseverance issue, instead of just shutting down, think of some different ways to approach it. You may agree with that, my assessment. You may think, oh, well, one of the other skills is also there. But that was just my quick and dirty attempt at that one. What I'd like you to do, and we're not going to have a chance, I think because of time, just to have a detailed conversation about this, but pick one of the practices for yourself and try to identify how it reflects the employability skills framework. At the end, we can talk about that if there's time, or you may be able to use the chat window and just share some of your thinking. Next slide. Meredith referred a bit to the educational functioning levels. There is some work going on with them for both English language arts literacy and also in mathematics. The CCR standards are intended to guide curriculum development, instruction, and professional development. The EFL descriptors guide state assessment for the national reporting accountability efforts. And as Meredith said, there are EFL descriptors. The old ones are now being worked on. In fact, Meredith and I are involved in that work. And they're being revised to reflect the CCR and also to reflect the employability skills framework. So just stay tuned for that work. And at this point, I think I will turn it over to my next colleague. Thank you.